Hello everyone, this is my ELP 101 project. Topic Op-amps or Operational Amplifiers. I am DEVANSH JAIN, entry number 2021TT11132. Operational Amplifier. Operational Amplifier Op-amp is a DC coupled high electronic voltage amplifier with a differential input and usually a single-ended output. The amplifier's differential inputs consist of a non-inverting input with voltage V plus and an inverting input with voltage V negative. As the name suggests, the purpose of an amplifier or an op-amp is to amplify or increase the input signal to produce an output signal which is much larger than that of the input, with a similar waveform as that of the input. The main change in the output signal will be the increase in the power level. This additional power is supplied by a DC voltage which is externally provided. The output signal is controlled by the input signal in an amplifier. 741 IC op-amp. 741 IC op-amp is one of the most successful operational amplifiers. Its configuration is: the pin 1 is the offset null, pin 2 is inverting input, pin 3 is non-inverting input, pin 4 is the negative power supply, pin 5 is the offset null, pin 6 is the output voltage terminal, pin 7 is the positive power supply terminal, and pin 8 is the no connection terminal. Inverting amplifier. An inverting amplifier, also known as inverting operational amplifier or an inverting op-amp, is a type of operational amplifier circuit which produces an output which is out of phase with respect to its input by 180 degrees. This means that if the input pulse is positive, then the output pulse will be negative and vice versa. An inverting amplifier circuit is built by grounding the positive input 3 of operational amplifier and connecting resistors Rn and RF pot between the inverting input and the signal source and amplifier output node. Now, if we calculate voltage gain in inverting op-amp, we are taking this negative input terminal node 2 and applying KCL here. So I in plus IF equals to 0. Now by Ohm's law I equals to V by R. So above equation becomes V in by Rn plus V0 by Rf equals to 0. Now V0 or V output, if we calculate, it will come out as V out is equals to minus A V in, where A is equals to Rf by Rn, which is also equals to voltage gain. Here the negative signs represents the inverting nature of the op-amp. Also, as we can see in this circuit, the input signal is a sinusoidal function, but the output signal is 180 degree out of phase with the input. Non-inverting amplifier. Non-inverting amplifier is an op-amp based amplifier with positive voltage gain. When we apply any signal to the non-inverting input, it does not change its polarity when it gets amplified at the output terminal. This is the circuit diagram of non-inverting amplifier. Voltage gain non-inverting op-amp. Here, in this circuit, we connect an external resistance R1 and a feedback resistance or pot resistance RF at inverting input. Now, by applying KCL here, V1 by R1 equals to V0 minus V1 by RF. Now, if we assume that the voltage applied at the non-inverting terminal is Vi, and we assume that the op-amp in the circuit is ideal, then V1 equals to Vi. So the equation 1 can be rewritten as Vi by R1 equals to V output by V output minus Vi by RF. If we calculate it, then it will come out as V output by V input equals to 1 plus RF by R1. So the closed loop voltage gain A of the circuit came out to be A equals to 1 plus RF by R1. Some applications of op-amps. They are used in analog filtering and signal processing. Op-amps are used in every electronic device where linear ICs are used. They are used in various fields like communications, power and signal sources, also to amplify audio signals in loudspeakers, etc. Inverting amplifier is used as trans-resistance amplifier or also known as trans-impedance amplifier circuit. Non-inverting op-amp circuits are used where high input impedance is necessary. Thank you.